Now, before starting to study about solenoid, let's see a simple diagram of how the magnetic field of a bar magnet is. This is how magnetic fields are. They are emerging from North Pole and entering from South Pole. What are these which are entering and emerging? These are magnetic lines of force which I used to represent magnetic field. Now, why did I draw this? That is because, just keep this picture in your mind. Now, we have already studied that current produces magnetic field. Also, that if there is a circular coil of current, that is circular conductor, then magnetic field is what? Is entering from one side and emerging from the other. That means a single loop is also behaving like a very thin magnet. But what if you have n number of turns? So that will actually work like a strong magnet. Okay. So this is what a solenoid is. A loops, metal conductors of n number of loops. This is how you draw solenoid. Okay. So this is how current in these loops are flowing. These are the backward portion. So current in the backward portion is from is this direction. Okay. So if I have to represent the direction of current in these loops, it will be like this, downwards. So magnetic field would be in this direction. That means magnetic field lines would be like this. They'll be emerging out from this portion and they'll be entering from this portion, right? So that is why this solenoid is considered as much stronger magnet than a single loop. So this is what a solenoid is. Circular loops or n number of turns of a straight conductor, that makes a solenoid. So this is also a principle by which we actually make a magnet. I'm going to talk to you about electromagnet in a while. But first, even stronger solenoids are considered or made how? We take a rectangular or cylindrical bar and above this bar fold the wires like this. Okay. So when you turn n number of turns on this conductor or metallic, what do you call it as? This is the core of this coil. So if the core is metallic, more number of lines are going to pass through the core. So it is going to behave like a good magnet or permanent or temporary magnet, not permanent. Why temporary magnet? Because magnetic field is going to exist in the region till the time current is flowing in the loop. The moment current stops, the whole magnetic activity stops. Alright. Now, this topic is not in your syllabus, but I would still like you to know about it. What are electromagnets and how they are made? What are simple magnets? Okay, we are end with that topic. What is a solenoid? Solenoid is the number of loops of a metallic conductor from which if you flow the current, the total magnetic field accumulates in the core region. They exit from one region, they enter from the another side, and that is why the solenoid behaves like a bar magnet. That is why I drew the picture of bar magnet first. Now, we are talking about magnet. Consider an iron piece. Okay, consider a similar shaped magnet piece. What is the difference between magnet and a non-magnetic material? A magnet and an iron differ in what ways? See, magnetic field is actually because of small magnetic domains which are present inside a magnet. So if this is a magnet, small magnetic domains, they will all be inclined in same direction, and that is why each individual small magnetic field adds up in the individual small magnetic field of other domain, and they ultimately sum up to create a large magnetic field. But in this case, iron, suppose this is an iron piece, iron is a ferromagnetic material. So iron also have such kind of domains, but the domains are randomly placed. Alright, so they are in zigzag pattern. So what happens is the domanicity or the overall domain effect or the magnetic effect of all the domains actually cancel out each other. But we have a method by which we can incline all these domains in one direction. How? I'll just pass a wire through from them. It's like this. I rolled it up in about wire. So what will happen? This is how I rolled my conducting coil across it. Now when the current is flowing in this wire, there will be magnetic field associated with this, because this is basically a solenoid. So there will be a unidirectional magnetic field which will exist in the core region of the solenoid, due to which what will happen? The magnetic field will be in this direction and it will be something like this. So this magnetic field will force the magnetic domains to get inclined in the same direction. So this is what will happen after some time. All the domains will go and they will get inclined in the same direction. That is why this is now a magnet. But it is magnet only till the time the current is flowing through the conductor. That is why it is called electromagnet. This iron piece became magnet due to the presence of electricity. So this makes up an electromagnet. So now you have a clear differentiation between what is an electromagnet and what is a magnet on the basis of small magnetic domains present inside an iron particle.